get started. Any company update?
So I've been sick all week. Um, I got sick
Yeah.
Wednesday. I'm still not feeling great. All we really got company update wise is we do have 150/90s coming. We seriously overpaid for them. So yeah, but I don't really see it getting better anytime soon. So we do have 150/90s coming. We are going to honor the price of the Tiny Box Green 2 for those who managed to get a wire in, and for those who didn't get a wire in, I think we're gonna do like a 15% price hike. We'll call it the Liberation Day tax. But I gotta set that up.
Okay, sounds good. Cool. Feel free to say no, but do you have anything to say for the new linearizer?
It's a lot better. It's good. The main thing I'm happy that it removes is the old linearizer had. Oh, we can also remove the block fork U up. It's not used anymore. Um, the old linearizer had a while loop, and would have to do O of n graph rewrites. It was O of log n graph rewrites. But the new one is just O of 1 graph rewrites. So that's pretty nice. It's a bit faster, and none of the slowness is in the linearizer itself. The thing I'm going to work on this week is I'm going to write a whole set of micro benchmarks for things like UOP creation and tupleize and toposort, and like the UOP children stuff. I think if I could get speed up there, that's like the biggest place that all the time's being spent now. But yeah, no, overall, I'm pretty happy with
You're
the
also
Python
interested
speed of the
in
project.
the multi-scheduling speed?
Yeah, so that one, the multi-speed is mostly going to just be rewriting multi. And that's, well,
That's not
so it's not really Python, no. I mean, Python speed should translate to multi-speed, but only in a linear, like a linear way. But the real thing for multi is just to go from O of n to O of 1. I have a small thing right up about it, but really what I want to do is think about how to support tens torrent with new
Mhm.
multi, because
Okay.
if you can support tens
Oh,
torrent,
yes.
you can really support everything.
We want each core kind of to be one small GPU.
Yeah, that's the basic idea. Each core is a GPU, and then you shard things in a two-dimensional way.
Mm.
And then, so you can like shard a matrix across the whole thing two-dimensionally. Because I'm starting to think that things are going to look more and more like the tens torrent hardware, in the sense of, actually, I was reading the Blackwell has a whole new kind of tensor core, GB200. And this new kind of tensor core, a few things. I didn't realize all tensor cores are basically systolic arrays, as far as I can tell. Like that's actually
Yeah.
how they're implemented. I didn't know
Uh-huh.
this. I didn't know that like the TPU actually just exposes the fact that it's a systolic array, but they all are systolic arrays. So yeah,
Great.
I've been having nice conversations with O3 about GPU microarchitecture. But yeah, so the B200 is basically a big systolic array. I think it's 128 by 128. So they're looking more and more like the TPU.
Great.
Yeah. So
What's fundamentally different between like 1D sharding versus like 2D sharding?
nothing fundamental. It's just you shard on two axes, right?
Yeah, but you can imagine that it's similar to you flatten that and just shard 1D.
Uh, you flatten it and shard 1D. Is that the same thing? Well, what do you mean by you flatten it? No, that's not the same thing. You can't do that.
So do you want to support like shard one way with copy and shard another way with like real shard? Because if we
What I
do
want to
copy,
do,
copy is If it's like copy, then it's the same as single copy, right? And if it's like real shard, then it's kind of similar to you do a real shard on your flatten. The only difference case I think is you copy shard one way and real shard another.
Uh, so I don't really see how it's the same thing, right? Like, think about just a matrix, and you're trying to shard it on 4 GPUs.
Mhm.
Right, so I have a 2D matrix, and I'm trying to shard it on 4 GPUs. So if I shard it on one axis, I'm going to get like 4 vertical lines. But if I shard it on two axes, I'm going to get 4 squares.
Mhm.
Yeah, but I don't think there's a way to like mimic that. I mean, yeah, sure, you could do like fancy
Yeah,
reshapes and
that's
swizzles
what
and stuff.
I was thinking.
Oh yeah, and that's I think fundamentally what it will be. I think we can totally do that, and
Yeah,
that's just a question of how to express it. But fundamentally, it's
yeah.
just the shape tracker, right? And like you want to kind of keep the view as expanded as possible, but
I think for 2D and maybe more sharding, it also we might need to start to think about your connection between shards are like not identical for overflows. No, we assume like your
uh,
P2P is the same, right?
I mean, TenStorrent shouldn't have to deal with that problem. Yeah, sure. Eventually, we'll get to heterogeneous
Like multi
communications and
machines.
things. Yeah, but that generally, I think, usually can be expressed. Yeah, sure. And then you're doing like something like max flow. Yeah, you should definitely be able to. Well,
Okay.
the new multi is going to have like an all reduce UOP, and then the all reduce UOP. We could have a separate thing which does the scheduling of that communication.
Yeah, that sounds good.
But no, I'm still going to work this week on, well, the other big thing that I want to do now that kernelize is merged is I want to do I want to refactor the JIT. I want to refactor the JIT to not have all those stupid classes anymore and just basically capture a kernelized thing.
Sounds good. We can talk about scheduler kernelize since we talk about it.
docs.tinygrad.org. There's kernelized section. You can read it. The idea basically is that we can have kernels inside the teacher. So what this allows us to do is to like build incrementally the schedule graph and then actually make the exec items out of it. So that's gonna like make the JIT much more simpler because right now the JIT is doing capturing of the ASD is doing 3 runs. It's running once to capture the ASDs, it's running the second time, and then it's running the third time. So this is gonna remove all that because the entire graph of kernels is captured in the tensor UOPS itself. So that is merged. I have a diff for backward. I don't know if it's correct. If you can take a look at that one. And yeah, pretty much that's
Which
it.
one?
9953. So it doesn't work with gradients because I want gradient to sort of treat the kernelize as a buffer. So that's the only thing that's left.
So, yeah, I see you saying here that you're treating a sign like detach. And saying it doesn't have a gradient. I don't necessarily think that's right. I mean, I don't know about how this interacts with backwards, but you should definitely be able to take the gradient of things that were assigned to, and it should work as you expect. Like, think about doing like ReLU in place. I mean, in Tinygrad, this stuff's a little bit different because it's not like really an assign. Like a sign doesn't always mean that it's going to be assigned. But I don't think treating it like detach is right. Like if you think about like a normal like gradient flow, if I have assigns, why should that affect anything?
I think you should just ignore it. The
But that's
gradient.
not what this does.
Yeah.
It doesn't ignore it. It treats it the same as detach. So what you're saying here is that gradients can't flow through a sign,
Yeah.
which I don't think is right, but it's okay. I think this is probably more correct than what's in there.
Currently it asserts because it tries to actually get the gradient of an assign. The
Yeah, yeah.
assign, from the perspective of the child tensor, is a buffer, is a load.
Well, but
So
not
and
always,
it's
right?
they always, in this case, always.
No, no, no. Come on. What if I? Oh, oh,
Yes.
because the assign UOP isn't created. If I don't have a buffer, it'll do a replace UOP.
Well, if you have a source as an assign, the thing that goes into the local kernel for that child is the buffer, not the assign. It doesn't mean anything to have an assign in the middle of the kernel, right? Assign is a memory boundary, just like how buffer or copy is a memory boundary.
Yeah, but where we have only tensor.py is enforcing this, right?
Yeah.
Yeah, I think it's fine for now, but I think that we should probably change the story around tensor. I think like we should always put the assign in the UOP graph and then remove assigns that don't make any sense later on. Like we shouldn't be using if statements in tensor to gate that.
Mm. Yeah.
But I think that can happen later. Yeah, no, good work getting it getting kernelized merged. I'll look over the docs and I'll check it out, make sure it's right tonight.
Yeah, I was reading the doc. I think it looks fine. Do you add this to CI as well to making sure the code is like runnable?
Oh, I think the test docs already checks that. Yeah.
Oh, so we check everything in the doc. I see.
Yeah, I think it
I mean,
just extracts it.
there's no asserts, but it actually runs in the doc.
Okay. Yeah, I mean, looks fine to me. I think for people in this call, if you're interested, go to docs.tinygrad.org/developer/kernelize. Read it, see if you can understand it. If not, feel free to post your feedback or like if you have any suggestions to the docs channel. And with that said, okay, let's go back to Bert. What did I do? I have a hack. I put in a hack to fuse a range, but only fuse it for embedding. I don't know how to not do that random. So for now, the hack is just saying if it's uint. There's another flag called fuse a range uint, and you can disable uint so that you won't fuse rand. And with that, I think that saves like 7 milliseconds for everyone. And for some reason, it doesn't really work for the MI300X ones. I don't understand. Anyway, I plan to do some submission candidate rounds this week. We are fairly close to the deadline. It's like 10 days. So I will prepare those, see where we are. try to get the single kernel softmax in. It adds a lot of total compute that I don't quite understand. I would probably look slightly more, but we will talk this in the RetinaNet. I would try to see if there's anything I can help this week for RetinaNet. We want to get something in for RetinaNet, so I'll probably do more of that instead of like tuning BERT more this week. I'll leave the BERT red run to Nimogen if he can find anything to fix the AM driver. Otherwise, I would just do what I'm doing now, which is running the beam with AM and running the real run with AMD. That's the only stable setup I can find to run this. And finally, for Henkel optimization, I made a few changes. I removed require optimization because by removing that, our gated load stay the same. Some kernel change slightly, but the benchmark compile 3 become faster. So the benefit of complexity, and no one really knows what that does. I just remove it. And with the removal of that, I can make Henkel optimization to just return a list of ops. Ops are the actions that we apply on the kernel. It was annoying because require optimization, you call it sometimes and it adds actions sometimes. So now Henkel optimization just return a list of op, and my next project after we wrap up MLPerf would be trying to find a better full pass or a better Henkel optimization. And that API is better because now we separate the creation of a kernel to like finding what actions are good to apply for the sake kernel.
Yeah, I really like the separation, and I think that those optimizations can start to go in the kernel graph. So like, yeah, like we could put it in the graph, such that it's not this like out of band thing anymore. Because I find it pretty annoying when I'm like working inside a tensor if I want to change the optimizations on something.
You need to print the ASD, then you.
Yeah, I mean, I know, I can schedule it and then hand create the kernel object and then optimize it. But so I think we should add a pass in between kernelize and schedule called like kernel optimize. And kernel optimize will add to each kernel in the tensor graph the optimizations. And it'll either get them from a hand coded policy or from a beam policy.
I see. Okay.
Yeah, so I would do it like that, and then we can totally separate that from the schedule. Yeah, it's like in the graph. Optimizations, connect to kernel.
Okay. That's my stuff. I mean, Fuata, if you want to speak, if you can speak now, you can speak now. Or hi.
Oh, hey. Yeah, so for RetinaNet, I think for the most part, I've just been, I've actually started working on the post processing. And I kind of spent some time on the beam stuff, so, but I'm switching gears onto that. But I think the beaming, the AMD driver, or sorry, the AMD driver, there's still some hanging issues. I extended the flag that Chen you suggested to be larger, but that didn't end up working, so it's still hanging. For the AM driver, I thought initially I was successful with both non-beam and beam benchmark runs, but at some point there will be a case where the loss is just NAND, and it's pretty difficult to reproduce on my end. So I guess I know Chinny, you mentioned about helping out on the RetinaNet, so maybe if you can help me out on that, and if there's anything you want me to add, like flags or anything like that, to help you assist with debugging it further, I can definitely do that.
Yeah. Okay. So I think we kind of only have this week, and we kind of want to submit something. So I think the priority would be have a setup, whatever, using AMD or AM driver. We probably need to still do beam, but we want something that can run on a red machine. So that's a priority. And I think, I don't know, maybe Nimogen can help with the AM issue, but I think I will try this, like the beam with AM, so that it doesn't hang and run with AMD thing, similar to how I'm doing BERT later. So I think that's one priority. Then another is we need to find a way to speed out the post processing. I think that's the kind of the most important one, because that dictates how many runs we can do. We need, I think 5.
Yeah.
So
Also, I was going to say
yeah,
the non-beam runs for both AM and AMD, if I remember correctly, they are stable. So obviously not going to be as fast as we wanted it to be, but we at least know the baseline of the non-beam runs are fine.
yeah, I mean, even if I said whatever time, we still want to give a like a representable, like good enough time. So I think what you can do is I'll check post processing, but you probably know more than me at this point. See like what's the error that can be run on device instead of NumPy and stuff. And also we need to start preparing the logging. Uh, I have a comment on your init MLperf thing, but other than that, we also need to do some logging because you only know the loggings are correct after you have a full run. And we need logging to be correct. So that's also important for us to make a run. But otherwise, looks good. We can continue thinking on this in the RetinaNet channel.
Okay, sounds good. Thank you.
With that said, let's move on to driver.
Yeah, so for the BERT run, so I'm testing these right now on 3 machines. So for Tiny 11, I haven't seen any nans, but it has another problem with file system, I guess. So just so it gets your error from time to time. So, but actually it was on the latest firmware. So for now, I just updated to the Tiny 13. And I'm just still testing these, like to the latest 6.4. So yeah, I'm just testing. So far so good, but yeah, it's only 2 runs. No. So yeah, I'll test it on the latest firmware. So we'll see. So yeah, because our fleet like uses pretty old 6.1.3 firmware. So yeah, maybe something wrong with this. So
So you think you can reproduce it, and you think it's the version. So if I want to do a run now, what would you like advise me to do? Like I pick a machine, how do I? Maybe you can post that in Bird channel or somewhere for the instructions for me to making sure I'm using the correct or your advice version.
Yeah, okay, I'll check. I'll check that. So if Tiny 13 is fine on this version, yeah, I'll post it.
Yeah, I really like the idea of grabbing the firmware from the web instead of relying on whatever happens to be on the machine. Like we should need nothing on the machine at all to run with the stuff, and then we can fetch always the same firmware version. So this is just never a machine specific thing.
Okay.
How big is all the firmware?
Oh, I know it's like 10 megabytes maybe.
Yeah, we should always be downloading that from the web. It shouldn't even be accessing it from the one that's on disk.
Yeah, so that's for the BERT. So for the speed, I also tested that, and so I looked into that. So there is pretty strange problem. Is that so running some kernels? So like the second run, or just like second, third, and so on runs, So they're just slower than the first run when it's running with AM. I tested the AMD GPU driver with their power management and with their stuff, but with MES disabled, so in their driver. So and they have the same problems. So, but if MES is enabled, so the kernels have pretty decent timing. So I'm not sure why that happens. But yeah, so still, I will take a look into that. So yeah.
Okay. I think it's only like 2-3% in terms of like our run, since this is more of a benchmark for us. I would prefer to use like AM like through, then we can in the next round we compare with our current run. So I will run whatever you recommend me to run with, and as long as it doesn't have NAND issue, I think 2-3% of it is fine. And it's not a top priority now to figure out why, if like that's the issue, unless you have a very easy fix. I think it's not that important now for this round, but we definitely want to fix that long term.
Yeah, so for yeah, okay, I'll post it once. Tiny13. Okay, I'll just test in Tiny13 and post it if it's good. So for the USB GPU, so yeah, actually we can patch the firmware for the 24 version. So yeah, writes are working. So I started moving some abstractions into master. So yeah. Yeah, so the current plan, I'll like merge all the abstraction we needed into master. Maybe I still think that I'm pretty close to the read thing to make it work, because actually, like the whole USB controller logic is pretty simple. It just has like one function to handle on all interrupts, and they have one big while loop. And I think in this while loop they should just pull somewhere inside this while loop. They should pull the NVMe. So yeah.
Yeah, we should make a repo with all our reverse engineering efforts on the firmware, and just whatever changes we have and all that.
Yeah. Yeah, maybe I have one. I just post something from time to time into. Yeah, maybe it's not the decent quality, but yeah, okay. So yeah, it's working. So the plan is just to get everything, like to get all the abstraction merged, and yeah, after that I'll just revisit the read speed.
Cool.
It's good. Okay, let's move on to web GPU. I guess for who the memory planning, whatever bench.
Yeah, I can comment on that. First, I just mentioned, of course, the planned refactoring of the JIT will be relevant for web GPU, so I'm interested in that. Yeah, so most of the stuff are not, I mean, the memory planning in the JIT thing, like the memory planning part of that PR actually probably isn't that important. I haven't really seen like I haven't tried really, but I haven't seen like a real memory savings where like on a real model that's actually large. But like the actual motivation and the important part of that PR is the part around model state. I think I've found what I would say is the most pure definition of, or the most pure way to define model state so far. It captures RNG buffers as well as KV cache. Basically, I mean, let me explain it this way. Why it's meaningful. So when tensor.realize finishes executing, all the buffers that are allocated during tensor.realize, in the exec items, they get garbage collected, like assuming you're not capturing with the JIT, they get garbage collected, except for, of course, the ones that are still attached to UOPS, which are attached to tensors, which are the ones that were the tensors that were realized, as well as all the other tensors alive in the program that were affected by becomes map. So, just the way that Tinygrad is set up right now, like those buffers that still are alive, those are the ones that need to persist between calls to the JIT, at least as far as I can tell. So the important part of that PR is just, that I capture those on the second call to the JIT. The ones that are realized after the buffers that are realized after the first call are marked on the second call to the JIT, and that's like the necessary and sufficient set of buffers that are needed to, take your model from where it was in Tinygrad and then pick it up where you left off elsewhere in another context.
Yeah, I mean, I don't think that that's right. I think that this is based on the assumption that buffers containing data that must persist after the first call to the JIT. Again, I think that that buffer could be allocated, that buffer could be not allocated. Whether it matters for the JIT, you can tell from the computation the JIT is doing, right? If you have a buffer there that happens to be allocated, that then is getting completely overwritten by the third kernel in the JIT and is never read from, there's no reason that buffer should be in your set.
You're right about that, in terms of it being completely overwritten and never read from again. But so the example I pointed out, right, the KV caches, those are not completely overwritten and they're read from again, but they're not captured by our previous definition of model state.
Well, then it might be wrong. That definition might be wrong. And I don't know if we're distinguishing overwritten completely versus not overwritten at all, but we definitely know that from the compute. But my problem with this way of doing it is it depends on really state that's completely arbitrary, when all of this state can be determined from what the computation is itself. You shouldn't be asking the question what. Yeah, you shouldn't be asking the question what buffers are allocated. You should be asking the question what bytes are being read from that are not written to by me, or being read to before they're written to by me.
Yeah, like we would have to go beyond just looking at the buffers. We'd have to look at the bytes. I think I agree with that.
Yeah, I mean, you can look at just the shape tracker on the output will tell you if something's going to be completely overwritten or not. If it's a mask store, it won't be, but that's like one line check. It's not a.
Yeah, I'll look at that. Thank you.
Cool.
But yeah, so the refactor of the JIT, like that could change the, together with the kernelized stuff. It's very interesting for this.
Well, if you want to start playing with that, go ahead. Similar to the prevent viz from blocking the GC of buffers PR, I commented on this, right? Like PRs like this are never going to be merged, right? A PR that explicitly adds 30 lines of code to work around something that's fundamentally wrong, right? Like when I see a function, you have a function called something like, restore original buff UOPS. That just shows something's wrong, right? That's like I would never merge something like that. Because it's not. Yes, I understand it may fix the problem, but it's not about fixing today's problem. It's about building the right thing for 5 years from now.
I agree with that philosophy.
Cool. Yeah. No. If you want to start, so I'm going to spend this week on micro benchmarks. If you want to start, like think about. Do you see what I mean by the new way to write the JIT with kernelize?
I mean, I understand the kernel graph. I think I do, but I can't like articulate it in a couple sentences.
Well, then, yeah, I mean, you're welcome to play with a PR that like just inherently by design fixes these things. You don't want to fix bugs. You want to design such that the bug is impossible.
I agree. And so just if we're talking about the Viz stuff, uh, it's just based on wanting to keep UOPs around, but having the problem that the buffers can't go away if the UOPs are around. So we would have to fix that.
Sounds good.
Or, sorry, did you say that made sense or?
I said, yeah, sounds good. Okay, we have to fix that. Cool.
Yeah. If anyone sees that, I'm happy to if anyone sees a quick, an easy fix for that, I'm happy to give up any share of the bounty. But yeah, I am interested, and I can't promise that I'll deliver something soon for that. But yeah, I agree. That would be the ideal solution.
Yeah, no, but I mean that's the whole that's the work figuring out how to do it, right? Like I don't see a quick fix, but I mean the first step kind of is to just figure out even what we are doing right now. I guess I don't really know.
Yeah.
Like,
So
what is the
for a
relationship?
suggestion to move this specific topic around, I think it would be useful if you just open an issue and kind of describe what you just said into the issue, like write it down, and also describe what we are doing now and what we expect it to be done or to be fixed. Because for now,
Okay.
even if you say, okay, someone maybe if you are interested can look into this. For now, for me, I don't like really understand what needs to be looked into, let alone like other people who might be interested in solving this. So I
I
think
mean, I write it.
documenting.
Was the PR not clear? Because I thought I thought I outlined it, but maybe it's too verbose.
Yeah,
I mean, I
but I
could try
mean,
to.
PR is a collection of like code change as in commit, right? It's not that effective to like really. You know this because you went through all the PR changes and iteration, but
Yep.
it's.
Yep. Okay. Yeah, I can open an
I
issue.
think having an issue would be nice.
Definitely. Thank you.
Okay. What's next? So we're done RetinaNet for Onyx. I will review the Hugging Faced CI thing later. Comment on that fuse because I also find it sometimes work and sometimes it doesn't work, and I'm not entirely sure why.
Do you have a bug? Do you have like a test that's failed?
Yeah, I can risk. It's not about like tests that fail. It's like every time I add fuse, it becomes slower.
Well, that's. I mean, so all I can do here is I can describe the behavior of fuse. And
No,
then
what I can
yeah.
do is I can give you an example and say fuse versus no fuse and why it double the flops or like double the ups or something.
Okay, I could look into those. I mean, what I'm really interested in is fuse versus no fuse. Like, fuse is wrong. And there's definitely things that don't linearize, but things that don't linearize are different from things that are wrong. It should never be wrong.
Yeah, I
It might
think
not
it's
linearize.
correct. I think it's correct. It's just for some reason it's doing like duplicate to computer or something.
If you have you write a test for it that just says has the two ways and says this one's doing like double the flops or something, and I can look. So it should be like an easy automated test to write. Just look at like global counters, global ups.
Yeah, sure. Yeah, I posted in Bird for the single kernel softmax, but I imagine that's too big of a test. I can find something that's similar. And specifically for sort, I understand sort use a lot of pads and making cat faster is a thing. So let's add the fuse arrange thing to the example, and maybe even better if we can add this as maybe find a smaller version of this and add it as a test, arrange test, or what file would be suitable for this. Basically, we want to understand the behavior, like what part it saves, like what kind of UOP it's saving and stuff. So that it's not only on this example, but it's on this pattern, and we have a way to maintain this pattern moving forward. At some point, we will make the fuse arrange behavior like a default, and at that point, having all these examples in test will help. Okay.
Sounds good.
And if you have anything, you can just post it in the, I don't know, the Fast Llama channel or something. You discover or anything you try but didn't work. I think those are so helpful in some way. Okay, let's move on to UVN stuff.
Yes. So, what is happening?
Hello.
Can you hear me?
Yes.
Okay, so the old InfiniBand stuff that just averaged the gradients in the step works fine on 3 GPUs. Each machine 3 GPUs, 2 machines, total 6 GPUs in ResNet, and it works fast. I think 1.5 times faster than just if I do this on one machine, but 6 GPUs just doesn't work. I think it doesn't work deterministically on the same
Wait.
step. I'm
Wait. So you're saying 3 GPUs on 2 machines each is faster
yeah,
than
this
one machine with 6 GPU?
works fine. 6 GPUs on. So if I have the same batch size across 2 machines, it's faster on ResNet, and it works fine. But it explodes, and it does it deterministically. So I think it's not related to InfiniBand. And I tried just adding a bunch of sleeps everywhere. Didn't fix that either.
Wait. Okay.
Wait.
Let's slow down and let's structure this. Okay. So in order to claim the bounty, I expect 3 GPUs on each machine. 6 GPUs on each machine doesn't have to work. But 3 GPUs on each machine does, and it should have speed very similar to 6 GPUs on one machine. Is that where we are?
Yeah. That's the old implementation that isn't cloud. That's just two processes a bunch of changes in the data loader, and inside of the step, average of the gradient. So I exchange the gradients between 2 machines, average them,
Oh,
and
wait. Hang on. There should be no distinction from a tinygrad perspective if the GPUs are on the same physical machine or on 2 different physical machines, right? The algorithm should be exactly the same. I expect this to be byte for byte identical.
So I'm talking about the old thing. The new thing with cloud that I'm currently doing, I haven't even got it working because there is I looked at the cloud, thought that it's gonna be easy, and it's not. There is a lot of stuff that doesn't work. There is 5 PRs open right now from me that fix some parts of it. And yeah, I don't know where I'm going to port it to cloud.
So I'm looking at these PRs, and again, I'm seeing things that are they look to me like multiple changes. Don't hard code default cloud dev, right? So there's a change there on line 169 that takes 3 lines and collapses it into 1, right? This is a white space change. White space changes should never coexist with non-white space changes.
Okay, yeah, I can split that into separate PR.
Cool. The PRs are they're too confusing for me to merge because there's too many things in there, right? This PR is very contained. It does this one thing. So yeah, don't hard code default cloud dev. Cool. I understand what that does, but the only change that should have is just the next device get available devices. Why is multiprocessing current process.name equals main process being removed?
I think I
I'm
have
I'm talking
to.
about PR 9935, and I see 3 completely different changes in there.
Yeah. Oh, I see. So it was before I changed to next get. So before I just changed that, it was in the like global variable, and for that I had to set the multiprocessing name before starting process. Otherwise, it would error because it didn't have the name main process. So yeah, I forgot to revert that change. Okay, I will split that into
Oh, so
separate
that got
files.
merged and shouldn't have gotten merged.
What?
The cloud,
What?
the multiprocessing main process thing. So that's in master right now, and it shouldn't be there.
Wait, what?
Are you saying the multiprocess? Are you saying setting the name to main process is in master right now, and it shouldn't be there?
No, I'm saying the first iteration of don't have code default cloud dev, this PR, did it differently, and that required setting the name here instead of, so like
Okay.
you can see line 127 where I
So
did.
you can
Yeah.
reverse something and make less. So you are saying you can reverse something that still does what you want it to do, but it's like less diff.
Hmm?
You
Can
can
you repeat
revert
that?
part of that PR and still does what you want.
Yeah, so I just forgot
Okay,
to revert
that's
that
great.
to my. Okay,
Okay, let's do
But
that.
yeah, no, but that should be, again, that should be a separate PR explaining this was added, it wasn't needed. Oh, cool, merge, right? The multiple cloud PRs open, I read them and I try to merge them. But again, you really got to empathize with me here and think, is George going to understand what this is? Is it one thing? Because if I can't merge it.
Okay, yeah.
I think this is the same advice we will give any Tinygrad contributors. It's a lot easier to merge 10 very small single focus item PRs than, I don't know, maybe like 3 PRs that try to save PR numbers or whatever, or because it's convenient to also change that. That's never convenient for the reviewers to merge stuff. It's a lot easier if you just split them out. It helps everyone. It makes merging PR a lot easier.
So the other thing with InfiniBand is that in
Well,
order
let's
to.
wait. Let's stop and let's pause now, and let's just focus on that. Let's just focus on getting the cloud stuff merged, simple PRs that I can just click merge on.
Okay, yeah.
Great.
Okay. Read. Okay, so bug fix for PTX broke again after the linearizer refactor. Okay.
Wait, something broke from the linearizer refactor?
I think it's because PTX is not the best code and it has weird workaround that is easily broken.
Oh, I see. Okay.
Cool. Can you add a test so that we at least know it's broken, kind of, or at least have something that indicates the state of this workaround? You know, it's a workaround. We might want to remove it, but good to have something that shows where we are. Sure. Then maybe just add TC equals to 3 somewhere in the test suite. It's fine to mark it as like something wrong, but yeah, just add something.
Yeah, TC equals 3 should definitely be in the test suite. I mean, again, when I did that linearizer refactor, the best I could do is just do all the tests and make sure the tests pass. It's hard for me to say, oh, there was this workaround and I have to go test that. Like, it's impossible.
Yeah, I think this is again a general advice. if you add something to Tinygrad and you want the maintainers to make sure that's correct, the best way you can do is add a test that tests the behavior you want. As long as it's like generic, not like a very specific test, I think it helps with future development speed as well. Okay, other bounties. We'll comment on the FP8. So I think I ask like all in Tinygrad implementation for Python backend. No, it's lines. I think I don't know. It can be made more compact. That's probably fine. But I made a comment that I don't understand why Yan is not supported. I think it should definitely be supported because FPA supports Yan, and otherwise, I think that looks fine. Either the author wants to make it compact, or if I merge it, I can probably like make it more compact. I think it's not a like huge blocker. I have people here working on stuff that I forget to mention. If so, just post in general.
I think
I don't think the metal multi-sync thing really fix it. It doesn't fix on benchmark, and the test is already passing on master. So I don't understand that.
oh, if it doesn't fix it on benchmark, then like that's where I wanted to re-enable it. If that thing doesn't fix it, I don't really
The author re-enable
understand.
it. The author re-enable it, but I run it on benchmark. It failed.
Yeah, okay. I don't know. Maybe that's just a bad bounty. A bunch of people have like put stuff for that, but if there's no way for people to verify it, then it can't really be a bounty.
I mean, the way to verify it is they just re-enable it, and we run on benchmark, and that's correct. And we understand why it was not correct.
Yeah, because if this doesn't work, this is the exact problem that I wanted fixed. Okay, cool.
For the Z3 stuff, I see good progress. I also see Quasling discussing things with Slycos on the PR.
Great.
Yeah, my only issue was there's a rules in the grouper that I don't think it should be part of that. Otherwise, I think the Z3 part and check out of bound basically rewriting our UOP expressions for index into Z3. I think those are good directions we want to see. So that part looks good to me. Pretty much it.
I wanted to briefly talk about the 10 torrent bounty. What I want to see in order to get that bounty lock is all of the ops text passing, and in such a way that doesn't like you can't just only use one core. Like you have to, in theory, your approach has to scale to the entire chip. All model tests don't need to pass in order for the lock. To claim the bounty you do, but just for the lock, just get ops passing.
And no limits on like making fast, as long as it's correct.
Yeah, I don't think we're gonna like it, with the speed thing. It's like if there's something deeply broken about your approach that will never ever get speed, then no, that's not okay. But if it's just like, oh well, I didn't add support for like the tensor and tensor cores, yeah, I think that's fine.
Yeah. Okay, I think that's pretty much it. Any last word?
Nope. I'm going back to sleep. I still feel awful. It's hard to think with a fever.
Okay, take care.
Right.
Yeah, take care. Thanks everyone. See you next week.
Thanks. See you all next week.